Good afternoon friends. Today we are together for a LVCOM lecture. Myself Shishangiya Jitendra from Atmiya Institute of Technology and Science Diploma Studies. Today we discuss about the question paper solution of electrical circuit, and the question paper was December 2010. So let's start with the question number 1. Question number 1. State and explain Ohm's law. Also give the limitation of Ohm's law. Explain factors affecting the resistance. Define resistivity and give its unit. See the question for 7 marks and ask in the different topics. So first we have to explain what is Ohm's law, and then we have to give the limitation of Ohm's law. In third part we have to explain the factors which are affecting the resistance, and in the fourth part what is the resistivity and its units. So clearly we have to mention all the things in our answer. So see, first Ohm's law. As shown in the figure, one voltage source V and one resistance R. Here we assume that the resistor is a pure conductor. So whenever we connect any pure conductor with a voltage source, there is a current passing through the conductor. Now this current is directly proportional to the applied voltage. That means how much current will flow, it is depends on the value of voltage source. So we can write down in easily one sentence. Ohm's law states that the potential difference or a voltage across an ideal conductor, or we can say resistance, is proportional to the current through it. That means V is directly proportional to the current. So let's see the relationship here. Voltage is always proportional to the current as per the Ohm's law. Now we know that we have to remove the proportionality sign and we have to put one constant. So we remove this proportionality sign and we put there one constant. So equation become V is equal to I into R. R is a constant, but here R is known as a resistance. Now the constant of this proportionality is called the resistance, and it is denoted by capital R. So how can be resistance can be find out from this equation, R equal to V upon I. Now that is the definition of resistance. Now second question is that define the how many factors affecting the resistance. We can also know the equation of Ohm's law. Equation can be easily transferred into the Ohm's triangle. See in the triangle, in a triangle we have to go with three parts. In first part we put V, second part we put I, and in third part we put R. Now see, in that triangle we show the relationship between voltage, current and resistance. So in that part here V, if we want to find out the voltage, then V equal to I into R. So in that triangle we can easily see I and R in nearer, so they are in multiplication. So if we want to find out voltage, then equation put V is equal to I R. It's a simple trick to remember the equation. Now go for second triangle. If I want to find out the current using Ohm's triangle, then simple, I equal to, see, V is upper part, R in lower part, then put in the numerator V and in denominator R. The simple equation is formed, I equal to V upon R. And similarly, if I want to find out the resistance, then equation is easy as we see previous slide. So R equal to V upon I. So by this triangle we can easily remember the Ohm's law relationship and formula of voltage, current and resistance. Now second question is Ohm's law limitations. There is a few limitations of Ohm's law. First thing is that this law cannot be applied to unilateral network. Means if any network having unilateral component, then Ohm's law cannot be applicable, because the characteristics of unilateral network is not a linear. So we can easily say that Ohm's law is applicable only for linear network. So another limitation is Ohm's law is also not applicable for non-linear network. As we seen, both points are quite similar, but the difference is that one is unilateral network and second is non-linear element. What is non-linear element? In a non-linear element, diode and transistor, SCR, all are the non-linear elements. So this rule cannot be applicable for diode, transistor or SCR like characteristics. The Ohm's law does not count the effect of change in temperature. We have to slightly discuss on that point, because when temperature is increasing, the resistance is slightly increasing, so it may be affect, but here we does not count the effect of temperature on any conductor. So it is a limitation of Ohm's law. So we have to remember this three limitation. Now third part of the question, which are the factor which affect the resistance? There is a few factor which affect the resistance. First factor, length of conductor. Second one is cross sectional area of a conductor. Third is material of conductor, and fourth one is temperature of conductor. So let's see one by one every point, how length of the conductor is affect the resistance. Projector please. First point, length of a conductor. So suppose I take one conductor of length L, and if I increase the length of conductor twice, then my resistance is also increased. Suppose the first resistance is R, then second resistance is 2R. That means resistance becomes twice. So length of the conductor is directly proportional to the resistance. So resistance is directly proportional to the length of conductor. R is directly proportional to the length. Now second point, resistance is depend on the cross sectional area of a conductor. Suppose having a one conductor having a cross sectional area A, if we increase the cross sectional area, twice A, then again resistance will be decreased, because the resistance is inversely proportional to area. Resistance is inversely proportional to area. So now by combining this 1 and 2, we can say that resistance is directly proportional to length, resistance is directly inversely proportional to the area, then resistance is proportional to the L upon A. And if we remove this proportionality sign, we put here R equal to rho L upon A. We will discuss this equation now later. So R equal to rho L upon A. So these two factors are mainly affect the resistance. Now as we seen in the slide, third point is material. Now material of the conductor. Suppose I am taking same length of copper wire and same length of aluminum wire, then as the crystalline structure of both the conductors are different, that means resistance are different. And also the temperature of conductor, the temperature also conductor is different, then resistance are different. So these four factors are mainly affected on the resistance. Now last point, what is resistivity? So from the derived equation, as we derive the equation, R equal to rho L upon A, where L is a length of conductor, R is a resistance of conductor, and capital A is a cross-sectional area of a conductor. So now question is arise, what is resistivity? So the constant, we put constant rho, the symbol rho is known as a resistivity. If we put rho, then A goes to the multiplication, that means R into A, and L comes into the denominator. The equation becomes of resistivity is rho equal to R A upon L. Now we are defining the resistivity. The resistance of conducting material having unit cross-sectional area and unit length is known as its specific resistance or resistivity. So see, the resistance of any conducting material which having a unit cross-sectional area and unit length means, as shown in the figure, the length is L and cross-sectional area is A. As shown in the figure, as we know in the equation, R equal to rho L upon A. So if length is 1 unit or 1 meter or 1 centimeter, area is also 1 meter square, then R becomes rho. That means the resistance becomes resistivity, or it's known as a specific resistance. So the resistance of conducting material if having unit cross sectional area and unit length, then it's known as a resistivity. So we know the equation, rho is equal to R A upon L. And one important for this question is find out the unit. If unit is not written, then mark will be deducted. So unit is ohm per meter square. So simply from the given equation we can remember this unit. We can also write that ohm into meter square, denominator meter, but this is the special trick to write down this unit. So we have to remember this equation. Okay, that was about the first question. Now second question. Before the second question, we see by one video that what is the actually Ohm's law.
Fundamental laws of electricity explains this relationship. George Simon Ohm, after whom this law is named, was a German physicist of the early 19th century who spent many years researching on the factors that affect current flow in a battery. He found that the current in a steady-state conductor is proportional to the voltage between the ends of the conductor. So if V is the potential difference of this conductor from point A to point B and a current I flows through it, I is proportional to V. What Ohm also discovered was that current is inversely proportional to the resistance offered by a conductor. What is resistance? Imagine a river flowing downstream from a mountain. The river will encounter several rocks and boulders which will block its flow. In other words, the rocks act as a resistance to the flow of the river. Similarly, conductors also offer resistance to the flow of current. So if R is the resistance of the conductor, I is inversely proportional to R. Combining these two terms, we get I is equal to VR or V is equal to IR. The reason why we represent Ohm's law as V is equal to IR is because it's a lot easier to print in textbooks and reading material. Let's dwell on this resistance a bit more. There are two kinds of resistances offered by a conductor. The first type is to do with the material of the conductor. As the free electrons travel through the conductor, they also experience a force from the positively charged nucleus of the conductor atoms. This force of attraction resists the flow of current. The attraction force is more in certain conductor materials and less in other, depending on the type of atoms they're composed of. The size and shape of the conductors also affects the resistance they offer to current flow. Instead of having a conductor of length L, let's take a conductor with double the length 2L. This now means that the electrons will have to travel double the distance as before. Double the distance means double the number of positively charged atoms to deal with along the way, hence in effect doubling the resistance offered by the conductor as a whole. The cross-sectional area also affects the resistance. Imagine 25 cars at a signal, all moving through a two-lane, one-way street. The traffic can move pretty fast now as there's lots of space for the cars to move. But what would happen if those same 25 cars had to go through a one-lane street instead? The traffic won't move freely anymore as we have only one lane instead of two lanes. Similarly, when we cut the cross-sectional area of the conductor by half, we are in effect reducing the movement space of the electrons by half and doubling the resistance. So if we sum all this up, R is proportional to the resistivity of the conductor material, which is denoted as ρ. R is proportional to length, and inversely proportional to the cross-sectional area, as decreasing the cross-sectional increases the resistance. Hence R is equal to ρ times L divided by A. R is quantified in ohms, named after the person who discovered it.
Okay, during the video we seen the various factor which is how affect the resistance and what is the actually Ohm's law. Now second and important question, derive the equation for star to delta transformation. One example is given in that question. Three resistance of 30 ohm, 40 ohm and 50 ohms are connected in a delta connection. Find the equivalent star connected resistance. So first we have to derive the star to delta transformation. That means we have to derive one relation between star to delta. How we can convert our star network into the delta network. As shown in the figure, the first figure shown the star network and second is the delta network. So how we can find out the value of delta resistance RA, RB and RC using star value resistance R1, R2 and R3. So that is called equivalency between star and delta is called star to delta transformation. So let's go with the transformation derivation. So see, projector, star to delta transformation. So as we have to see in a star network, one resistance, second and